I have some personal experiences with heat bursts, this meteorological phenomenon that takes place. It's fascinating, and it's a great Morse code topic.
I can't wait.
It's a relatively rare phenomenon, but we've seen some recent examples of them here in the Dakotas, so I thought this would be a good time to talk about what causes heat bursts. So it's a downburst of warm and dry air that sometimes happens with dissipating showers and thunderstorms. This was an example from a few weeks ago, September 10th in Ashley, North Dakota, when the temperature went from 66 degrees to 86 degrees at about 5 a.m. in the morning. So this is a nocturnal weather phenomenon. It usually happens in the late evening and overnight hours when you get the dry and warm air from a dying thunderstorm or shower to come down to the surface and cause for a rapid temperature rise. So the science behind the heat burst is you have that colder air coming down from the storm, but there's dry air and warm air in place underneath the thunderstorm or shower cloud. So that rain evaporates. So no rain falls to the surface, and that cooler air warms as it comes closer to the ground from compressional warming. We'll get into what that means in a little bit. So by the time it reaches the surface, it's very warm and dry air, and you can get very gusty winds with these heat bursts. So normally when we see these thunderstorms form, there's rapidly rising warm and moist air, and at the peak of them, that warm and humid air is ingested into the storm, causing for large cumulonimbus clouds. We get frequent lightning and thunder and heavy rain. But as the storm is dying and it's dissipating, it becomes downdraft dominant. So the cool air wins out. There's less warm air coming up into the storm and rising, so there's more cool air sinking. But remember, for a heat burst to occur, we need dry air in place underneath our thunderstorm cloud. So as that rain comes into the dry air, all of it just evaporates. And that causes for the air to warm eventually, and then for that air to be compressed as it gets closer to the ground, leading to a gust of warm and dry air near the surface. So as the storm continues to weaken, that cool air plunges downward, but it compresses, that warms the air, allowing it to heat up, and that reaches the ground as a warm and sometimes very strong wind. This was an example from Yankton, South Dakota last weekend. Around 6 a.m., the temperature went from 70 to 90 degrees in 10 minutes with weakening showers nearby. The dew point tanked as well. So with that dry air coming down to the ground underneath that dying thunderstorm and showers nearby, the atmospheric pressure dropped and then rose quickly as well. This was from Foster Bay, South Dakota on September 9th. Again, earlier this month, around midnight, the temperature spiked to 93 degrees and the humidity dropped quickly. So these heat bursts are most common at night because thunderstorms are typically associated with daytime heating, that diurnal process where the sun is heating the ground. You get that rising warm and moist air to form the thunderstorms in the first place. But the thunderstorms lose the sun's energy at night and sometimes dissipate during the evening, allowing for the heat burst to occur. This was on August 3rd of 2008, around 4 a.m. in Sioux Falls, South Dakota. The temperature went from the 70s to 101 degrees. Imagine that at 4 a.m. with 50 to 60 mile-per-hour wind gusts. So sometimes these heat bursts can cause damaging wind gusts. In Wichita, Kansas, around midnight in June of 2011, there were 70 to 80 mile-per-hour wind gusts with a heat burst when there were dying thunderstorms nearby, and the temperature went from 85 to 102 degrees in the middle of the night. Pretty remarkable. But again, you need this layer of dry air in place. So we can look at that with a sounding or a plot of temperature and dew point all the way up through the atmosphere. And when the dew point and temperature line are separated, that indicates where that dry air is aloft. So we need that middle layer of the atmosphere to be hot and dry. That allows for all the rain to evaporate and just for that warm, sometimes hot air to descend quickly, causing for these strong gusts of wind. So here's kind of a schematic that I put together describing the heat burst science. So typically when thunderstorms decay, there is enough rain to survive that dry air aloft. So you still can see rain coming down to the surface, but if there's not enough rain left in those thunderstorms, or the air in that middle layer of the atmosphere is too dry, all the precipitation evaporates. Now initially the evaporation cools part of this layer. We call that evaporational cooling. So the cooler air that's more dense, that's heavier, so it sinks faster. But eventually, once all the moisture and all that rain gets evaporated in this dry and warm layer of the atmosphere, the descending dry air warms up due to compression. So then we get that very warm blob of air coming down quickly to the ground. Once it hits the ground, it spreads out in all directions, creating for that warm gust of wind that we call a heat burst. So the compressional warming, the science behind that, pressure is higher closer to the ground than it is higher up in the atmosphere. Based on the ideal gas law, the pressure as pressure increases, so as our blob of air is going closer to the ground with a higher pressure, the volume decreases and the temperature increases. So we have a cooler blob of air higher up, but it gets squished or compressed as it gets closer to the ground and warms up. That's why we can see those rapid rises in temperature with these heat bursts. You need that dry and warm layer of air aloft. So that's why we typically see these heat bursts occur in the plains or the desert southwest when it's a dry atmosphere and all that rain from a dying thunderstorm just evaporates and we get the strong, warm gust of wind at the surface called a heat burst, and that can spike really quickly with the temperature.
Does it ever, right? I remember specifically when I worked at KMOT in the late 90s, I think it was 98, summer of 98 or 99, we had a heat burst outside the KMOT TV studios. We went from like 70 degrees, let's say, showers coming in from the west, like Burlington toward Minot, and then the showers were dying. Yep. The air was compressing. It shot up to, I want to say 102. I don't remember specifically being so many years ago, but it went way up. We had a weather station at the station, and we were watching it spike. It was crazy. Same concept. Exactly. Compressional warming.
All right, good stuff. Thanks, Jacob.
You're welcome.